Hello everyone, welcome to the solutions for MET 2023. We are done with the objective questions. Make sure you check the videos that are already uploaded and we start with the subjective ones. Now this question can look like a question based on functions, graphs, etc. but it is mostly based on quadratic equations and algebra. Alright. Although the first part contains some hint of functions and graphs, let us look into the solution. So how does the function look like? Now to decide that, you just need to put the values in your mind and imagine how the function looks like, right? So p1x would be x plus 1 by x, p2x would be x square plus 1 by x square, p3x would be x cube plus 1 by x cube. So it looks very nice, alright? And we just have to sketch the first one, right? We don't have to sketch any of the others. So quite easy. Let's try to solve it. The first part says sketch the graph of y equal to p1x. So y is basically x plus 1 by x. Now to sketch the graphs, we calculate the first derivative, right? So the derivative, first derivative would be 1 minus 1 by x square, and we set this to be 0, right, to check the inflection points. So inflection points or the turning points, those would be where the derivative is 0. So this means we would be ending up with 1 equal to 1 by x square. So this gives us x equal to plus minus 1. Now at x equal to 1, y would be equal to 1. At x equal to minus 1, y is equal to minus 1, minus 1, minus 2. Alright, so the inflection points are very symmetric. The function will turn at 1 comma 2 and minus 1 comma minus 2. It's an hyperbola, so you can imagine how it looks like. I will try to draw it. Wait. Here. So if this is the axis, then the graph will look like this and that. And where would the turning points be? That are the points that we calculated. The first one was 1 comma 2 and this one is minus 1 comma minus 2, right? So this is the coordinate axis. I hope you can make sense of it. It's a very rough diagram, but then again this suffices. Alright, I hope my face is not blocking it off. Check the graph, it should be clear right now. Okay, so hyperbola, x plus 1 by x, it turns at 1 comma 2 and minus 1 comma minus 2. That is done, and that finishes the entire portion of functions and graphs that we have been dealing with. Now all of the other parts are based on simple algebra, so let us try to solve those parts. We have a proof, p2x equal to p1x square minus 2. This is quite easy. You just write down p1x. P1x is x plus 1 by x, right? Square it, you will get p1x whole square equal to x square plus 1 by x square, a square plus b square plus 2ab, right? So 2 into x plus 1 by x will just give you 2. Now this is p2x, so p1x square minus 2 equal to p2x, right? How did I do this? I brought that 2 to that side and I kept this as p2x, right, because that is the definition, p2x. Alright, so I think this one is done. I don't have to show anything else. No, this is done. The next one says find the expression for p3x in terms of p1x. Alright, let us look for p3x. We will use the same technique, p3x, right? Instead of p3x we start with p1x because we have to find it in terms of p1x, right? So p1x equal to x plus 1 by x, and then we cube it. So p1x whole cube, this will give you x cube plus 1 by x cube, right? A cube plus b cube plus 3ab, which is just 3 into a plus b. Now again we can do the replacements, so that will give us p1x whole cube equal to p3x plus 3 into p1x. Now we need to express p3x in terms of p1x, right? So p3x would be p1x whole cube minus 3p1x. Done. Part 4. Find all real solutions. Alright. X to the power 4 plus x cube minus 10x square. Is it minus? Yes. Plus x plus 1. Now the hint to this question is in these terms. Alright. Now see, they are x4 and x cube and x and 1. They are equidistant from the middle term. Right? By the middle term I mean x square. So x to the power 4, the highest term, is 2 degrees away from x square. Then x cube is 1 degree away. Right? X is 1 degree away to the left hand side, and 1, which is x to the power 0, is again 2 degrees away on the left hand side. Alright, so we have 2 degrees on the right hand side for the highest power, 2 degrees on the left hand side for the lowest power. Highest power is x to the power 4, lowest power is x to the power 0, which is 1. Okay, so using this hint we will divide this entire expression by x square. If we do that, we end up with x square plus x minus 10 plus 1 by x plus 1 by x square equal to 0. Why does this happen? Because we divide by x square not equals to 0. Why is x square not equals to 0? Because x is not equals to 0. That is given. Alright. So again, this becomes quite easy because we have x square plus 1 by x square. I am just grouping the terms together. Plus x plus 1 by x minus 10 equal to 0. Right, now this becomes p2x plus p1x minus 10 equal to minus 10 equals to 0. Now p2x I had calculated in the second part, right? P2x is p1x square minus 2. Now this minus 2 and this minus 10 will make minus 12. So I'll get p1x whole square plus p1x minus 12 equal to 0. Now you can do it all cutesy and be like, let p1x equal to m, and then you can write it as m square plus m minus 12 equal to 0, which would give you m plus 4 into m minus 3 equal to 0. So that would mean m equal to 3 comma minus 4. Now this means that p1x, which is equal to x plus 1 by x, is equal to 3, and x plus 1 by x equal to minus 4. Again, quadratic equations, so I can write this by multiplication format. It will become x square minus 3x plus 1 equal to 0 and x square plus 4x plus 1 equal to 0. Now neither of these are factorizable, right? So these cannot be middle termed, so you'd have to use the quadratic formula. If I use the quadratic formula, x becomes, for the first term, minus b, minus of minus 3 plus 3 plus minus root over of b square minus 4ac. B square is 9, 4ac, 4 into 1 into 1, 4, 9 minus 4, 5. So I don't need that long of a square root. Plus minus root 5 by 2. And this one is minus b. So minus 4 plus minus root over of 4 square, 16 minus 4, 12 by 2. Now root 12 is 2 root 3. So I can simplify this as x equal to 3 plus root 5 plus minus root 5 by 2 for the first one. And then this is minus 2 plus minus root 3. How? Because minus 4 plus minus 2 root 3, I can divide the 2, and this gives me the solution of the the fourth part. Find all real solutions. Now these are all real, so I have 4 solutions in total. By the exact same logic, we will do the fifth part. Alright, now the fifth part requires a bit larger calculation, so I have put it in a separate page, and let us begin with the calculations here. Alright, so how do we decide what to check here? Now again, I would urge you to observe the power. It's x to the power 7, right? So the central power will be somewhere here, isn't it? X to the power 4 x cube. We would have to do something there, but you cannot find a central power because there are total even number of terms, right? You had learned this in statistics when you learned about median. So if there are total odd number of terms, you can find a central term and then divide. That will make your life much more easier. But here we have even number of terms, so in the case of median we would have to take the mean of the two central terms, but here we cannot do that, right? We would need an integer power to break this down into quadratic equations. So that means this expression should be divisible by something. If we can take that out, then we have a polynomial that will have odd number of terms, and we can figure out the center and do all of the calculations that we did in part 4. So how would we figure out what factor to take out? Easy, you can use the factor theorem. The factor theorem will state that, well, it I cannot say the factor theorem will state it, but the factor theorem states that if x minus a is a factor, then you would have p of a equal to 0 for any polynomial p of x. Alright, and vice versa, if p of a equal to 0, then x minus a is a factor. We will use the reverse technique, the vice versa part. Alright, so how do we decide which constants to check? That will depend on the last constant. The last constant is -1, so that means whichever factors we have should have their constants multiplied together and resulting in -1. Now this only happens if the constants are either +1 and -1 or -1 or +1. In any case, we would have to check two different values, 1 and -1. So you can either go ascending or descending. We will go ascending. So if we go via ascending order, and just for the sake of convenience, I'll name this as fx. Alright, let us name this thing as fx. So let us check f of -1 first. F of -1 will mean I have -1 to the power 7, so -1. This is x to the power 6 is 1, so +2, fine, +5, -7, -7, +5, +2, -1. So this gives me -14. See, 7 cancels. Then I have 7 cancels, but this becomes -2. So this is non-zero. So that means f1 should be equal to 0. Right? I don't have to check it because it's 1 into -1. If -1 is 0, then f1 will have to be 0. You can check it on your own if you want. But this implies that x minus 1 is a factor. Alright, if that happens, then we can decompose it. So if x minus 1 is a factor, then fx will be equal to, I can take x to the power, I'll just keep a line gap, x to the power 6 into x minus 1. That would give me x to the power 7 minus x to the power 6. Right? So I would have to make it 2x to the power 6. That would give me 3x to the power 5 here into x minus 1. So that would be 3x to the power 6 minus 3x to the power 5. Again I have minus 2x to the power 4 into x minus 1. So that would give me minus 2x to the power 5 plus 2x to the power 4. Now I would have to reach minus 7x to the power 4, right? So it will be minus 9x cube into x minus 1. So that would give me minus 9x to the power 4 plus 9x cube. Right, now I have to get back to 7x cube, so I'll do minus 2x square into x minus 1. So that would give me minus 2x cube plus 2x square. Then I would have to go plus 3x into x minus 1, which would give me plus 3x square plus 3x, and then I would have to, sorry, minus 3x. Right, and then I can just go minus 1, right? So no, plus 1 into x minus 1. That would give me plus x minus 1. So minus 3x plus x will be minus 2x and minus 1. Alright, so what do I end up with? I end up with x minus 1 into x to the power 6 plus 3x to the power 5 minus 2x to the power 4 minus 9x cube minus 2x square plus 3x plus 1. Alright, huge equation. And as you can see that the powers are symmetric once again, right? And they are symmetric about x cube. So we have to find the roots of fx, right? Now one of the roots are fixed anyway. So if I set fx equal to 0, then x equal to 1 is a root. And for the other one, I name this as f1x. I have to check x to the power 6 plus 3x to the power 5 minus 2x to the power 4 minus 9x cube minus 2x square plus 3x plus 1. I have to check the roots of these. So I divide by x cube and I'll get, this is set to be 0, right? So I'll get x cube plus 3x square minus 2x minus 9 minus 2 by x plus 3 by x square. I hope you are getting the drift right now. So now I can combine these, x cube plus 1 by x cube, right, plus 3 into x square plus 1 by x square plus no minus 2 into x plus 1 by x minus 9 equal to 0. So this will give me p3x plus 3p2x minus 2p1x minus 9 equal to 0. Now we use the values that we learnt. So p3x was, I can check it from the previous question, right? So p3x was, what did we calculate it as? p1x cube minus 3p1x. So p1x whole cube minus 3p1x, and this is thrice of p2x. Okay, that is p1x square minus 2, right? Quick check. That was given here, p1x square minus 2. Fine, no issues there. p1x square minus 2, and then we have minus 2p1x minus 9 equal to 0. So again we can use that substitution format, right? Let p1x equal to m, because it gets a bit complicated here. So you get m cube minus 3m plus 3m square minus 2 minus 2m minus 9 equal to 0. That would give you m cube minus 3m plus 3m square is minus 6 minus 2m minus 15 equal to 0. This means m cube minus 5m plus 3m square minus 15 equal to 0. Alright, I can see the substitutions or the solutions. So m into m minus 5, m square minus 5 plus 3 into m square minus 5. So that would give me m plus 3 into m square minus 5 equal to 0. So this would give me m equal to minus 3 comma plus minus root 5. Now this is just 3 quadratic equations that you have to solve, right? M is p1x, so I have x plus 1 by x equal to minus 3. I have x plus 1 by x equal to root 5. I have x plus 1 by x equal to minus root 5. Right, these are the 3 equations that I have to solve. Now let's see, this becomes x square plus 3x plus 1 equals to 0. This becomes x square minus root 5x plus 1 equal to 0. This becomes x square plus root 5x plus 1 equals to 0. Now I'll name this 1, 2 and 3. So very quickly, number 1, it will solve into x equal to minus 3 plus minus root over b square minus 4ac. Okay, this is done. Number 2 will leave x equal to plus minus, oh sorry, minus b. So minus root 5 will give us just root 5 plus minus root over of b square. Now b square is just 5 minus 4ac, so minus 4 by 2. Okay, so this is root 5 by 2, both of them, right, because they are equal roots. So fine, let them be equal roots because plus minus 1 is just 1. Alright, root 5 by 2, and number 3 we have x equal to minus root 5 plus minus root over of b square. B square will be 5 again, minus 4ac, that will be 4 by 2. So this is, I'm sorry, this is not equal, right? This is 1 here. So minus root 5 plus minus 1 by 2. So how many solutions of x do we get? Let us list them down. Roots of x, roots of fx, right? So I had the first one as x equal to 1. right? X equal to 1. Then we had these two, minus 3 plus minus root 5 by 2. Then we had these, right? Root 5 plus minus 1 by 2, and then we had this minus root 5 plus minus 1 by 2. So total of 7 roots, and here we have a 7-degree polynomial, right? So 7 roots, 7-degree polynomials satisfies the fundamental theorem of algebra, and that is your answer. Okay, so as you can see, basically quadratic equation, but quite a bit longer, because you would have to stack the variables one by one, and then you would take one factor out, and then you would have to factorize it. So any minor mistake will get you into an unfactorizable problem. And anyway, most of the values of x that we obtain are from the quadratic formula, right? So even if you go wrong somewhere, you wouldn't realize it very soon. Now, how do we know that we are on the right track? The first check that you would have to conclude is where you substitute m. Before the point you are substituting m, if you do not get the symmetry here, right? So x cube and 1 by x cube together, x square plus 1 by x squared together, x and 1 by x together, if you do not get the coefficient symmetric, that means you have made a mistake in the algebra somewhere. Alright, so once you reach that stage and you have the symmetry intact, then you can be quite sure that you are on the right track. After that, you would just replace the values, or if you can handle writing p1x again and again, then you can go forward with that. I usually do not try to write p1 of x because it takes time, right? I can just substitute it by a different value and then do it faster. Okay, so sometimes you have to be smarter, because in an exam you not only have to deal with the difficult questions and answers, but also you would have to deal with a shortage of time. Alright, so if you can shave time of certain sums, please do it, because any time saved is time gained. Okay, now this video has become quite long because, well, it was a subjective question. It had to be worked out step by step. Now I hope you have understood all the steps. If not, do rewind and rewatch the particular segments. I'm sure you will understand it. Even if you do not understand it, then you can post your problems down in the comment section. Our team will surely get back to you. Alright, so with this I'll end the video, and in the next one we will look into the next subjective problem. Okay, take care.